Hi, I'm Byron Riggins. I'm a native Philadelphian, converted Californian, and currently a California Sea Grant State Fellow with the Delta Stewardship Council's Delta Science Program in Sacramento, California. In celebration of National Estuaries Week, I'd like to share with you some of the research I've done through San Francisco State University on the edges of the San Francisco Estuary and how this research connects to the system's health and resilience. The San Francisco Estuary is the largest in Western North America. Its watershed encompasses nearly 60,000 square miles and 40% of California's land. Fresh water flows from the mountains into the Central Valley, converging in the Sacramento-San Joaquin Delta. There, it mixes with salty water from the Pacific Ocean that is carried through the San Francisco Bay by tides. The rivers connect to the delta and ocean via the estuary, and the estuary connects species, ways of life, and adventures. This merger is the foundation of the estuary's rich biodiversity, providing homes to a vast array of species including mammals, fishes, shorebirds, and plants. My master's research centered on the intertidal habitat along the edges of the seaward end of the estuary where water meets land. This is referred to as a marine riparian area. The term riparian describes land habitats that are next to freshwater streams and rivers, but is increasingly being used to describe land habitats next to salty marine habitats as well. Marine riparian areas have not been well studied, but the work that has been done suggests it provides ecosystem services similar to traditional riparian zones, such as absorbing excess nutrients before they enter the water, absorbing wave energy, which discourages erosion, storing carbon, which is a greenhouse gas, and the tissues of algae that inhabit these areas, and providing refuge for small organisms from the sun. I wanted to understand more about the role that a local seaweed called rockweed plays in providing habitat to small animals and supporting the larger ocean food web. Using published research I used to design my methods, I picked 4 sites along the shores of the San Francisco Estuary. Within those sites, I studied 1 square foot beds of rockweed and gathered physical information like density and height. I also counted a variety of invertebrates in the beds, recording data like which species they were and information about them such as size. From these sites, I learned 3 main things. First, rockweed patches are denser in spring and fall when sunlight and nutrients are more available. Second, invertebrates living within rockweed beds were most abundant following blooms in late spring when snowmelt-derived nutrients were carried to the estuary. They were also abundant in late fall when phytoplankton bloomed due to nutrients that creeped into the estuary during summer. Invertebrates were less abundant higher in the intertidal zone, where they were more prone to drying out and being eaten by other species like shorebirds. So why does this matter? Today, marine riparian areas are being squeezed out from climate change-induced sea level rise on one side and coastal development on the other. While rockweed may not receive as much attention, it provides fundamental services and resources that allow other species to directly or indirectly thrive, like crabs, herring, shorebirds, or harbor seals. If we lose these systems, we may lose their environmental and economic benefits such as coastal protection, as well as opportunities for recreation, education, and culture. So, what can you do as an estuary enthusiast? If you haven't already, you can check out marine riparian habitats near you, such as San Francisco State University's Estuary and Ocean Science Center, or Tiburon's Brickyard Park, or even Angel Island, but be sure to tread carefully. You can volunteer to join celebrations like National Estuaries Week each September, or the Estuary and Ocean Science Center's Discovery Day at the end of April. To adapt the saying by the great scientist Sylvia Earle, let's protect our estuaries as if our lives depended on it, because they actually do.